right, let's look at your sample test for Chapter 12, your conic sections. So for number 1, it asks us to find the equation of the parabola with vertex 2, 1 and focus 2, 4. Now, even though I only have to find the equation, it's helpful just to sketch a little graph so that I can see what I'm working with. So I'm going to come over here and I'm going to plot the vertex at 2, 1 and the focus at 2, 4. Remember that your parabola will always wrap around your focus. So that's how I know that this is going to open up. So if it opens up, then that is the equation, x minus h squared is equal to 4p times y minus k. And my vertex, of course, is my hk. So let's go ahead and put 2 in for h and 1 in for k. So now all I need to do is just find my p-value. P is the distance from the vertex to the focus. So the vertex was at 2, 1, the focus is at 2, 4, so the distance from 1 to 4 is just 3. So that means P is 3. I also knew that P is a positive 3 because it's opening up. So P is positive when it's opening up. If it had been opening down, then P would have been a negative 3. So if we put a positive 3 in for P, 4 times 3 would be 12, and there's my equation for my parabola. All right, look at another one of those. So this time they tell me that my focus is at negative 6, 0, and my directrix is x equals 4. So again, let's go ahead and sketch what we know. Our focus is at negative 6, 0, and our directrix is at x is equal to 4. All right, now we know that the vertex is the same distance away from the focus as it is from the directrix. That means it has to be right in the middle of that focus and that directrix, or halfway between them, or like the midpoint, all right? So halfway between negative 6 and positive 4 is, if you go through and say the distance between negative 6 and 4 is 10, so half of that would be 5. So start right here and go over 1, 2, 3, 4, 5. Or start here and go over 1, 2, 3, 4, 5. Either case, you can see your vertex would be at negative 1, 0. All right, so if my vertex is negative 1, 0, remember that's my HK. And again, my parabola has got to wrap around my focus. So I know that this one is going to open to the left. All right, so if it's opening left, then my equation would be y minus k squared is equal to 4p x minus h. Let's go ahead and put negative 1 in for h. Now be careful, this is not h. H is the value subtracted from x. So I'm going to put negative 1 in for h, so x minus a negative 1. And I'm going to put 0 in for k, so y minus 0. Of course, x minus a negative 1 would be x plus 1. And then I just need to find my p-value. All right, so p is the distance from the focus to the vertex, or from the vertex to the directrix, either one, that would be 5. And because it's opening to the left, it's going to be a negative 5. If it had been opening to the right, it would have been a positive 5. All right, so I'm going to go ahead and put negative 5 in for p, so 4 times negative 5 is going to give me negative 20. And then, of course, y minus 0 is just y, so y squared equals negative 20 times x plus 1. All right, then for number 3, we're going to go the opposite way. They're going to give me the equation and ask me to find all the information. So the equation that they give me is y minus 2 squared is equal to 8 times x plus 1. Now, if I look on my formula sheet, the way that I can tell whether it's a horizontal axis or a vertical axis with the parabola, look for the squared term. Okay, so if you'll notice in my equation, y was squared, x was not. So if I go look at my equations, I want the one where y is squared and x is not. So that is a horizontal axis. That means that it opens either left or right. Okay, so if I lay my equation right underneath that, then I can match it up, and you can see that this, again, think of this as the opposite of h. So the opposite of positive 1 would be negative 1 for h. And then the opposite of k, the opposite of negative 2 would be positive 2 for k. There's my vertex. All right, and then we also want to know our focus and our directrix. So we need to know our p-value. Now, if you'll notice, 4p is in the same place as 8. So if I set 4p equal to 8, divide both sides by 4, I'll get p is equal to a positive 2. So because it's positive, it opens right. If it had been negative, it would have opened left. All right, so I'm going to start right here at my vertex, and I know it's going to open to the right. And my distance from the vertex to the focus is my p-value, and again, p was 2. So I'm going to start right here at my vertex and go over 1, 2, and that will put me at my focus. So my focus would be 1, 2. I'm going to start at my vertex, and I'm going to back up 2, 1, 2, and that would put me at my directrix. Now, remember the directrix is a line. So you're not going to say that it's a point like, -3, 2, or even just -3. You want to give the equation of a vertical line. The equation of a vertical line is x equals that value. So x equals -3 would be our directrix. All right, for number 4, same idea. They give me an equation and they ask me to find the vertex, focus, directrix, and the graph. All right. So again, the way I know which one I want is I'm going to look for the square term. X is squared, Y is not. So when I look at my formulas, I want the one where X is squared and Y is not. So that is a vertical axis, one that's opening up or down. All right, so if I match this up, you can see the opposite of H would be the opposite of -3, so +3. The opposite of K would be the opposite of +1, so -1. There's my vertex. All right, then if I come over here and notice 4p is in the same place as -16, so if 4p equals -16, divide both sides by 4, and p is equal to a -4. So if p is negative, it opens down. If p had been positive, it would have opened up. All right, so I'm going to start at my vertex, which was 3, -1, and I'm going to draw it so that it opens down. And remember that p is the distance from the vertex to the focus, and p was 4. So I'm going to start right here and go down 1, 2, 3, 4. So if I was at 3, -1, now I'm at 3, -5. And from my vertex, I'm going to go up my p-value to get to my directrix. So again, p was 4. I'll start here and go up 1, 2, 3, 4. And that will put me at +3. All right, now that's a horizontal line for my directrix. So the equation of every horizontal line is y equals something. So I want to say y equals 3 for my directrix. All right, then number 5, use completing the square to write the equation in standard form. All right, if you'll notice, I have a y squared. I do not have an x squared. So this has to be a parabola. Both an ellipse and a hyperbola have both x squared and y squared. If it has one or the other, either the y squared or the x squared, then this is a parabola. All right, so the y square that's what I want to complete the square with. So I'm going to come down here and I'm going to get my y terms together and leave room to complete the square. And then I'm going to move everything else to the other side and get it out of the way. So let's add the 12x to the other side and let's subtract the 4 over to the other side. To complete the square, we take the coefficient of the middle term, so 8, cut it in half, and then square it. Coefficient of the middle term, 8, cut in half would be 4, squared would be 16, so I'm going to add 16. And what I do to one side, I also have to do to the other side. All right, so we added 16 to both sides. So I should have created a perfect square here, meaning that when I factor it, I'll get the same factor twice. So I would get y plus 4 times y plus 4, or y plus 4 squared. And then over here, the -4 and the 16 would give me +12. So for standard form, I just want to take out any greatest common factor over here. So I'll take out my 12, and that will leave me with x plus 1. And that would be my standard form. All right, so those are our parabolas. Let's talk about our ellipses now. All right, so for number 6, it asks us to find the equation of the ellipse with center at 2, -4, vertex at 7, -4, and focus at 6, -4. So again, even though they didn't tell me to graph this, I'm going to give myself a little sketch just so I can see what I'm working with over here. Now remember that your foci are always on your major axis, and remember your vertices are the endpoints of your major axis. So I can see if this is my center and this is my focus, or if this is my center and this is my vertex, my major axis is going to be horizontal. So as soon as I figure out my major axis is horizontal, I'm going to go copy that equation down for major axis horizontal. They told me that my center was 2, -4, so my center is HK, so let's put 2 in for H. So right here, put 2 in for H, and then -4 in for K. So right here, -4 in for K. So y minus a -4 is going to give us y plus 4 in just a second. All right, now we just need to find A and B. So A is the distance from the center to the end of the major axis, from the center to the vertex. So my center was at 2. My vertex was at 7, so the distance between 2 and 7 is 5, so A is 5. So if A is 5, I'm going to put that right here, and 5 squared is going to give me 25. The other thing I know is the distance from the center to the focus. The distance from the center to the focus is our C value. So the distance from 2 to 6 would be 4, so that means that C is equal to 4. Now, if I know A and C, I can find B by using this equation. So let's plug in what we know. We know that A is 5 and we know C is 4. And then we can use that to solve for B. All right, so let's subtract 25 from both sides. We'll have -b squared is -9. Divide both sides by -1. So b squared is equal to 9, or b is equal to 3. And really what I'm looking for in my equation is b squared. So you could think of that as 3 squared or 9, either one, and that finishes off our equation. All right, then for number 7, another one of those, find the equation of the ellipse that has vertices at 0, 3 and 0, -3. And foci at 0, 2 and 0, -2. Okay, so again, let's plot what we know. Vertex at 0, 3 and 0, -3. Focus at 0, 2 and 0, -2. All right, so your center has to be halfway between your two vertices, and your center has to be halfway between your two foci. So either one of those will tell you that your center is going to be at 0, 0. We also know that the foci and the vertices are on the major axis, so that lets us know that it's going to be major axis vertical. So looking at our formulas, major axis vertical is this equation right here, so let's use that one. And let's go ahead and put in our vertex. So our vertex was 0, 0. Let's put that in for H and K. So 0 in for H and 0 in for K. So that's just going to give us x squared over b squared and y squared over a squared. All right, now we need to find A and B. A is the distance from the center to the vertex. So the center was at 0 and the vertex was at 3. So that distance is 3. So A is 3. So we'll have 3 squared or 9 right here. And then C is the distance from the center to the focus. So the distance from the center to the focus was 2. So I know C is 2. And so again, I can find B if I know A and C. So I can just say that b squared is going to be a squared minus c squared, or 9 minus 4. So b squared is going to be 5. So let's go ahead and replace b squared with what it's equal to with 5, and that's our equation. All right, for number 8, they gave us the equation and asked us for all of the information. All right, so the way that I know with an ellipse which is my major axis is that it is the larger one. So when I look at 36 and 16, because 36 is bigger and 36 is with x, then I know that the major axis is going to be horizontal, right? So I'm going to go grab my equation for major axis horizontal. And so that would be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Now, you'll notice nothing's being subtracted from x or y in this equation. That just means that my center is 0, 0. And so that's why we've just written this as, instead of x minus 0 squared, we've written it as x squared. And instead of y minus 0 squared, we've written it as y squared. Okay, so I know my center. My center is 0, 0. All right, then if a squared is in the same place as 36, then a would have to be 6. And if b squared is in the same place as 16, then b would have to be 4. So again, if I know a and b, I can use that to find c. So we're going to say 36 minus 16 is going to give us 20. So if 20 equals c squared, then the square root of 20, or 2 square roots of 5, would be equal to c. All right, so now let's go find what we know. We said our center was 0, 0. And we said our major axis was horizontal. So we're going to start here and we're going to go horizontally our a value in both directions, because a is the distance from the center to the end of the major axis, the vertex. So if I start here at 0, 0 and I go 6 to the right, I'm at 6, 0 for one vertex. And if I go 6 to the left, I'm at negative 6, 0 for my other vertex. All right. The distance from the center to the end of the minor axis is my b value. B was 4, so if I start right here and I go up 4 and I go down 4, those will be the endpoints of my minor axis, or my co-vertices. So my co-vertices would be 0, 4, and 0, negative 4. Then my foci. For my foci, they are always on the major axis. So since major axis was horizontal, my c value is 2 square roots of 5. So I'm going to start right here at my center, and I'm going to go forward 2 square roots of 5, and I'm going to go backward 2 square roots of 5 to get my 2 foci. And then my eccentricity is just my c value divided by my a value. So 2 square roots of 5 divided by 6 is going to give us the square root of 5 over 3. All right, then the last thing we need to do is sketch our graph. So we have already found the vertices, the endpoints of our major axis, and the co-vertices, the endpoints of our minor axis. So all I need to do is just connect those 4 points, and I'll have my graph. Now, you also can do your graphs on your Conic app, and we'll look at one of those at the very end. All right, then for number 9, here's another one like that. So for number 9, again, the way I know what my major axis is it's the larger one. So you can see 25 is bigger than 16. So that 25 is with y. So that means the major axis is going to be vertical. All right, so I'm going to go on my formula sheet and I'm going to grab the equation for major axis vertical. There it is right there. And I'm going to put my equation right underneath it so that I can line them up. All right, so to begin with, they want to know the center. All right, our center is HK, so we can see right here the opposite of H. So opposite of negative 3 would be positive 3. And then opposite of K, opposite of positive 2 would be negative 2. So there's my center, 3, negative 2. All right, I also can see that A squared matches up with 25, so that means that A is 5. And B squared matches up with 16, so B is 4. And again, using that same equation, once I know A and B, I can use that to find C. So 25 minus 16 would give me 9. If C squared is 9, then C is going to be a positive or negative 3. Okay, so let's start at our center. Our center was 3, negative 2. And our major axis was vertical. So we're going to start at our center and we're going to go up our A value to get to the end point of our major axis, our vertex. And we're going to go down our A value to get to the end point of the major axis, our vertex. So since A was 5, if I start right here at 3, negative 2, and I go up 5, 1, 2, 3, 4, 5, I would be at 3, 3. And if I start at 3, negative 2, and go down 5, 1, 2, 3, 4, 5, I'll be at 3, negative 7. So those are going to be my vertices, 3, 3, and 3, negative 7. The distance from the center to the end of my minor axis is my b value. So the distance from the center to the co-vertex is going to be b. So if b is 4, if I start right here at 3, -2, and I go over 1, 2, 3, 4, I would be at 7, -2. And if I start at 3, -2 and go back 4, 1, 2, 3, 4, I would be at -1, -2. So those are my two co-vertices. My foci are always on the major axis, and we said the major axis was vertical. So I'm going to start at my center. The distance from the center to my focus is my C value, and C was 3. So I'm going to start right here, and I'm going to go up 1, 2, 3. And I'm going to start right here and go down 1, 2, 3. And that will give me my two foci at 3, 1 and 3, -5. And then my eccentricity is my C value divided by my A value. So C was 3 and A was 5. So my eccentricity would just be 3 divided by 5. All right, then to sketch the graph, we've already found our vertices, the endpoints of our major axis, and our co-vertices, the endpoints of our minor axis. So all we need to do is just connect those 4 points to get our ellipse. All right, then use completing the square to write the equation in standard form. Now, if you'll notice, I have an x squared and a y squared, and they're both positive. So this is an ellipse. If one's positive and one's negative, it's a hyperbola. All right, so this is going to be an ellipse, and I'm going to need to complete the square for x, and I'm going to need to complete the square for y. All right, so I'm going to start off by getting all of my x terms together. So 9x squared minus 36x. Then get all my y terms together, 4y squared plus 8y. And then move this constant over to the other side. Okay, to complete the square, your leading coefficient has got to be 1. So I've got to get rid of this 9. So I'm going to factor it out. So if I factor out that 9, if I take 9 out of 9x squared, that leaves x squared. And if I take 9 out of -36x, that leaves -4x. Same thing here. I need to get rid of this 4, so I'm going to factor it out. So if we factor out that 4, 4y squared take out the 4 would just be y squared, and 8y take out the 4 would be 2y. Okay, to complete the square, we take the coefficient of the middle term, -4, cut it in half, and square it. Take the coefficient of the middle term, -4, cut it in half, -2, and square it, +4, and that's what I'm going to add right there to complete the square. Now, what I add to one side, I have to add to the other side, but be careful. That 4 was inside parentheses that were being multiplied by 9. So what did I really add there? I really added 9 times 4. I really added 36, right? And so that's why we add 36 to the other side to balance that out. What you do to one side, you do to the other. All right, look at the next one. So for this next one, coefficient of the middle term is 2. So cut that in half and square it to complete the square. All right, so coefficient of the middle term, 2, cut in half would be 1, squared would be 1, and so we're going to add 1 to complete the square. Now, what did I really add to that side? That 1 is inside parentheses being multiplied by 4. So what I really added to that side was 4. And so I need to add 4 to the other side to balance that out. Okay, the reason we call this completing the square is what we should have created right here is a perfect square, meaning when we factor it, we should get that binomial times itself. So we would get x minus 2 times x minus 2 for x squared minus 4x plus 4. And we would get y plus 1 and y plus 1 for y squared plus 2y plus 1. And then over here, the -4 and the +4 drop each other out, and we're left with 36. Now, in standard form, your ellipse and hyperbola always have to be set equal to 1, right? So let's divide both sides by 36 so that they'll be set equal to 1. So over here, when I divide, the 9 and the 36 simplifies to 4 in the denominator. The 4 and the 36 simplifies to 9 in the denominator, and then we have our 1. So there is our standard form for our ellipse. All right, and now let's talk about hyperbolas. All right, so they ask us to find the equation of the hyperbola with a focus at 0, 2, and 0, -8, and length of the conjugate axis 4. All right, so again, I don't have to graph this for them. I'm doing it for me just to envision what I'm working with. So I have a focus at 0, 2, and a focus at 0, -8. My foci are always on the major axis. So I know my major axis is going to be vertical. So as soon as I figure that out, I'm going to go copy that equation off of my note sheet for major axis vertical. All right. I need my center, HK, and I need A and B. All right. So let's talk about HK. Your center has got to be halfway between those two foci, right? Like the midpoint of those two foci. So I could say halfway in between -8 and +2 would be a -3. So you can see from -8 to 2 is 10. So if we go 1, 2, 3, 4, 5, or if we go 1, 2, 3, 4, 5, in either case, we're going to be at 0, -3. That's our center. Now, be careful. 0 is H. So don't put your 0 right here. 0 is H. Put 0 in for H. And then -3 is K, so put -3 in for K. So y minus a -3, or the opposite of -3, would be +3. And then, of course, x minus 0 would just give me x squared. Now I need to find A and B. All right. So the other fact that they told me was that the length of the conjugate axis is 4. Now, we know that the length of the conjugate axis is 2b. So if we set 2b equal to 4, divide both sides by 2, we find out that b is 2. So let's go ahead and put 2 in for b right there. So 2 squared would be 4. We also know the distance from the center to the focus is our c value. So the distance from -3 to +2 is 5. So our c value is 5. So if B is 2 and C is 5, I can plug those in and use those to find A. All right, so when we plug in 2 for B, we have 4, plug in 5 for C, 5 squared is 25, subtract the 4 from both sides, and we'll get A squared is equal to 21. So remember, what we're actually trying to find here is A squared. A would be the square root of 21, but what we want is A squared, so we can just put our 21 there. All right, look at another one of those. So for this one, they tell me that I have a focus at 4, 5 and at 10, 5, and I have a vertex at 9, 5. All right, so again, let's plot what we know. We have a focus at 4, 5 and at 10, 5, and we have a vertex at 9, 5. Okay, so my foci and my vertices are always on my major axis. So I automatically know my major axis is horizontal. So I'm going to go ahead and go grab my equation for major axis horizontal. And what I need is HK, my vertex, and my center, and then A and B. All right, so let's start with the center. Your center is going to be halfway between your two foci, right? Like the midpoint of those two foci. So halfway in between 4 and 10 is going to be 7. So, 4 go over 3, 10 go back 3. In either case, we're going to be at 7, 5. So let's go ahead and put 7 in for H and 5 in for K. Now we just need to find A and B. A is the distance from our center to our vertex. So we know that our center is at 7, 5 and our vertex is at 9, 5. So the distance from 7, 5 to 9, 5 is just going to be 2. So A will be 2. So let's go ahead and put 2 in the place of A. So that's going to give us 4 right there. All right, then we also know the distance from the center to the focus is C. So we know the distance from the center, 7, 5, to the focus, 10, 5. So the distance from 7, 5 to 10, 5 would be 3, so C is 3. So if A is 2 and C is 3, then I can use that to find B. All right, so we're going to say that B squared is 3 squared minus 2 squared, or 9 minus 4, so B squared is 5. So again, what I'm looking for is b squared. So yes, b is the square root of 5, but what I want is b squared, so we would put in 5. All right, for number 13, going the opposite way. This time they give me the equation y squared over 16 minus x squared over 25 is equal to 1. And you can see nothing is being subtracted from x and y. That just means my center is going to be 0, 0. All right. Remember that for an ellipse, for a hyperbola, it is not the larger one. For a hyperbola, it is the positive one. So since y is positive, then major axis is going to be vertical. All right, so I'm going to go grab my major axis vertical equation. And again, normally we would say y minus k squared x minus h squared, but we've already said that our center is 0, 0. So we'll use that as just plain y squared and x squared to make it a little easier to work with. All right, so now if I match up my equation, I can see that a squared is in the place of 16, so a would be 4. B squared is in the place of 25, so B would be 5. And if I know A and B, then I can use that to find C. So we could say 4 squared plus 5 squared is equal to C squared. So 16 plus 25 would be 41. So C squared is 41, or C is plus or minus the square root of 41. All right, so we've already said that our center was 0, 0 because nothing is being subtracted from x and nothing is being subtracted from y. So let's start at 0, 0, and we've said that our major axis is vertical. So we're going to start at 0, 0, and we're going to go up our a value and down our a value because a is the distance from the center to the end of the major axis, the distance from the center to the vertex. So if a was 4, I'll start at 0, 0 and go up 4. That would give me one vertex at 0, 4. And I'll go down 4. That would give me the other vertex at 0, negative 4. My foci are also on my major axis, so I'm going to start right here at 0, and I'm going to go up my C value because C is the distance from the center to the focus. My C value is square root of 41, so I'm going to start right here and go up the square root of 41, and start right here and go down the square root of 41, and so that will give me my foci at 0 square root of 41 and 0 negative square root of 41. Then eccentricity is my C value divided by my A value. So C was square root of 41 and A was 4. So just square root of 41 over 4. And then my asymptotes, again, when my major axis is vertical, this is the equation for my asymptotes. So I need to put in K. Remember that HK is 0, 0, right? So we're going to put 0 in for K. Then we need A over B. So A was 4, B was 5, so 4 over 5. Then we need H. H was 0, so we'll put 0 in for H. So that would just give me plus or minus 4/5 times x, or plus or minus 4/5 x for my asymptotes. All right, so now to sketch our graph. Let's start at our center, 0, 0. And we've already figured out our vertices when we went up 4 and down 4. So those are our vertices, the endpoints of our major axis. B is 5, so if we start here and we go forward 5 and we go backward 5, that will give us the endpoints of our minor axis. So whereas with an ellipse we connected those with an oval, we're going to connect those 4 points right there with a rectangle. So once I connect my 4 points with a rectangle, the diagonals of that rectangle will be my asymptotes. And you can see that if I had graphed y is equal to plus or minus 4/5 x, that's a y-intercept of 0 and a rise over run of 4/5. So, y-intercept of 0, rise 1, 2, 3, 4, run 1, 2, 3, 4, 5. That's exactly what that is. So you could graph them by the equation if you would prefer. This is just giving us an easy way that we can find those asymptotes to graph. All right, so to draw your actual hyperbola, you are going to start at your vertex and approach the asymptote. start at the vertex, approach the asymptote. So there's my first branch. And then start at the vertex, approach the asymptote, and approach the asymptote. There's my second branch. So when major axis is vertical, that's the one that opens up and down. All right, look at another one of those. So for this one, given the equation x minus 3 squared over 9 minus y plus 2 squared over 16 is equal to 1. Again, we want to find all of the craziness. All right, so to begin with, remember your major axis is the positive one, not the bigger one, the positive one. So since the positive one was x, my major axis is going to be horizontal. So I'm going to go grab my equation for major axis horizontal off of my formula sheet, and then I'm going to lay my problem directly underneath it so that I can compare them. All right? So to begin with, you can see that the opposite of h would be the opposite of -3, +3, and the opposite of k would be the opposite of +2, -2. So there's my center, 3, -2. All right, then you can also see that a squared matches up with 9, so a is 3, and b squared matches up with 16, so b is 4. And once I know a and b, then I can put that into my equation to figure out what my c value would be. So 3 squared plus 4 squared is going to give us 25. So if c squared is 25, then c would be plus or minus 5. All right, so they asked us for our center. We've got that. They asked us for our vertices. All right, so let's start at our center. The vertices are the endpoints of the major axis, and we said major was horizontal. So we're going to start right here, and we're going to go forward our a value and backward our a value. So a was 3, the distance from the center to the vertex, distance from the center to the end of the major axis. So if I start right here at 3, -2, and I go forward 3, I'm at 6, -2, and if I go backwards 3, I'm at 0, -2. So those are my two vertices. All right, my foci are also on the major axis, and so if I start at my center, C is the distance from the center to the focus, and C was 5. So I'm going to start right here at 3, -2, and I'm going to add 5. That'd be 8, -2. And start at 3, -2, and subtract 5. That'd be -2, -2. So those are my two foci. All right, then my eccentricity is just my C value divided by my A value. So C was 5 and A was 3, so that'll give us 5/3. Asymptotes, when our major axis is horizontal, this is the equation for our asymptotes. So let's plug in K. K was -2. B over A. B was 4, A was 3, so 4/3. And H was 3, so we'll put 3 in for H. So there's the equation for our asymptotes. All right, then they ask us for the length of the transverse axis. The length of the transverse axis is the major axis, so the length of the transverse axis is going to be 2A. And so if A was 3, then 2 times 3 is going to give us 6. All right, the length of the conjugate axis is the minor axis, and so the conjugate axis is 2b long, and if b is 4, then we can say 2 times 4 is 8. And then last, they wanted our graph. So we have already found our center and our vertices. All right, so if we start at our center and we use our b value, b is the distance from the center to the end of the minor axis. So the distance from the center to the end of the minor axis is 4. So I'm going to start right here and go up 4 and go down 4. So I'm going to take my two vertices, the endpoints of my major axis, and the endpoints of my minor axis. I'm going to use those 4 points to make a rectangle. So just like with an ellipse, we make an oval. With a hyperbola, we make a rectangle, right? The diagonals of that rectangle are our asymptotes. And so to draw our graph, we start at our vertex and approach the asymptote. Start at the vertex, approach the asymptote. So there's one branch. start at the vertex, approach the asymptote, start at the vertex, approach the asymptote. There's my other branch. So when my major axis is horizontal, it opens right and left. Now, one of the things that I told you was that you could use the Conic app on your calculator to help you with your graphing. So let me remind you of how we do that. So first, on your calculator, you're going to go to Apps right here. And when you do, this screen will come up. You may not have all these apps. That's perfectly fine. But go to wherever your Conic app is. So you can scroll down to Conic and hit Enter. And when you do, it will look like this. So then you can choose any one of the Conic sections. So the one we were just doing was a hyperbola. So I'm going to select hyperbola. And when I do, it gives me the option of a hyperbola that opens left and right and a hyperbola that opens up and down. So if you remember, the one we were just working with was one that opened left and right that had the major axis horizontal. So I'm going to choose that first one. And then it will let me define A, B, H, and K. Now please be very careful. In your equation, this is a 9 down here. 9 is 3 squared. Make sure you put 3 in for A, not 9. All right. Same thing here. This was 16. So that would be 4 squared. So let's make sure we put 4 in for B. And then our H was 3 and our K was -2. All right. So once I enter those, then I can just hit my graph button. So just hit your little graph button right there. And when you do, it will sketch the graph of your Conic section for you. All right, and you can use that for all of our Conic sections.